Hello and good day, everyone. So we are now down to our last topic for beam design, which is the design of reinforced concrete beam. So last time we started discussing it about the design criteria for RCB. So this time I will discuss the design procedure of it. Okay, so let's start. Okay, so first is there are 7 steps in designing of reinforced concrete beam. So first is to determine the design load. Okay, so as you recall, we already discussed in structural loads the different type no the different possible combination of loads. So we have the live, we have the dead, and we also have the snow. Okay, so use that formula to calculate the design load. The next thing to do is to determine the design moment. Okay, so design moment can be calculated if you draw the shear and moment diagram. You can calculate the maximum moment, then you will use that maximum moment in your design. The next one is calculate the reinforcement or the reinforcement ratio. So we have a formula for this, how to calculate the reinforcement ratio. So reinforcement ratio is just the ratio of steel bars over the concrete. Then next one is calculate the size of the beam. So size of the beam is simply the dimension. So you have the width and the depth, but it's different now, okay, because we will consider the steel bar. Next is we will calculate the area of the steel or the main steel area. Then if you can calculate the main steel area, we can determine now the number of main bars. Then after that, we will just do detailing check so that we can check if our design is safe or not. Okay, so I think the best thing to describe the design procedure is by simply giving you an example. Okay, so I have here. Okay, so design a 20 feet long simply supported beam to resist dead load of 1.5 kips per feet and live load of 2 kips per feet. So take FC equals to 4 ksi and Fy equals to 60 ksi. Okay, so this FC is just the strength of the concrete. Remember, FC is for concrete. Then Fy is the strength for steel. So remember that FC and Fy. So we have 4 ksi and 60 ksi. Okay, so this is now the configuration of your beam. So the span is 20 feet. Then this W is just the total of your structural load. So we have the live loads and the dead loads. So just add that, or you can use the formula. You can use the formula I presented in structural loads so that you can calculate the design load. Okay, so let's start solving. So this is the design solution. So first thing to do is to calculate the design load. So you recall here, this is from the presentation of structural loads. So this is the possible combination of load type of loads. Okay, so we have the dead alone, we have the dead plus the live and snow or rain. But the problem for this problem is there are only two, the dead and the live. So we will use this second formula, which is 1.2d plus 1.6l. We will neglect this 0.5 since we have no rain or snow load. Okay, so use that formula, just plug and play lang. Input nyo ang dead load, which is 1.5, then live load is 2. Then you can calculate the design load is 5 kip per feet. Okay, so we're done for the first step. Now let's proceed to the second step, which is determine the design moment. Okay, so by simply looking at the configuration of your run, it is simply supported. Then the types of loading is uniformly distributed. So we can say that the maximum bending moment of it is WL squared over 8. But so we have here mu equals WL squared over 8. Okay, so we calculated that the smaller W is 5, then the length, the span is 20 feet, then over 8. I multiply it by 12 since in order to convert into feet into inch, because normally the size of the beam is expressed in inch, not in feet. So, but if you don't want, if you're confused, you can actually use cancel this 12, then you have 30 keep feet. Okay, so I just multiply by 12 it so that it is easy for me to design beam in which it is expressed in inch. Okay, so we're done in second step. Now let's proceed to the third step, which is to calculate the reinforcement or the reinforcement ratio. So we have here the formula for reinforcement ratio. So it is rho equals to 0.85 fc over fy beta 1, I think sigma, epsilon c over epsilon c plus epsilon s. Okay, this fc is just the strength or the force of the concrete, then the force for the steel. Beta, it's a constant for concrete, which is 0.85. Then this is the epsilon, which is the strength of the concrete. Then epsilon s is the strength of the steel. So just substitute lang. You have 0.85 multiplied by 4 over 60 multiplied by 0.85. The strength of the concrete is 0.002. We have a formula for this, but I will attach the reading material for it as slide presentation, but we will not include that in our discussion because it's quite difficult to discuss the flexural analysis for reinforced concrete beam using this asynchronous mode of teaching. Okay, so I, I will not include that in my exam, but just read na lang sa attach reading material for it. So 0.003 for concrete, then 0.009 for steel. So we have a reinforcement ratio of 1.2%. So I express that into percent because it is easy to understand, because it is ratio. But during calculation, you can express that in this amount. So it's 0.012. So this is now the configuration of our beam. So we have this beam, the concrete beam, then we have the reinforcement. Okay, so after reinforcement ratio, we need to calculate the size. Okay, remember that we need to calculate the D and B. But before anything else, kindly look at this figure here. That D is the distance from the top of your beam going to the center of the steel bar. Remember, center of the steel bar. So we have here, from this center here going down is unidentified na distance. So we need to calculate that. We need to find that so that we can calculate the total size of or the total depth of your beam. Okay, so let's proceed. Let's calculate the size. So we have here an expression we use to calculate the beam. Okay, so BD squared equals to MU, which is MU is the design moment. Then P, it is constant, 0.94 concrete. Then rho, which is the reinforcement ratio. Fy is the strength, the force of the steel. Then we have this quantity, 1 minus rho Fy over 1.7 Fc. So just substitute lang, 3,000, 0.9, 0.012, 60, then the quantity of 1 minus multiplied by 0.012 times 60 divided by 1.7 multiplied by 4. Then you can have this equation that BD squared is just equal to 5,177.875 inch cube. Okay, so since designing, we need to decide what should be the dimension of our concrete. So we need a trial and error state. Okay, so let's use this table to express now. Let's say that I will use 12 inch. I decided that I will use 12 inch, 14 inch, and 16 inch. So which of these width will correspond to a safety dimension for D? Okay, so we need to calculate the D using the equation here, this equation. So by calculating, we can calculate that the corresponding D for 12 is 20.77, for 14 is 19.231, then 16 is 18. So there are 3, but which of these 3 is we need to use? Okay, So first is we need to calculate the D over B ratio. So for 12, 1.73. For 14 is 1. Divide lang ha. 20 divide 12. So for 14 is 1.37, then 1.8. Okay, so which of these we need should I use? Okay, so I will use the 14 inches. So I adjust, instead of 19.231, I increase that into 19.5. So why? Because remember that the DB ratio for reinforced concrete beam must range from 1.2 to 1.5. If there are two that will satisfy this boundary, then you can decide of one of so the very uh, you need to consider is the economic of your beam design. Okay, so if it is safety, then it's good, then proceed to economic, so which is economical to use. Okay, so because I think it's quite okay, no? So wala man po tayo example nga duha pa, so siguro you can find an example for that. Okay, so next thing to do is to calculate the steel area. So we have the formula of rho BD. Or remember, rho is just the reinforcement ratio. Then just substitute. Then you can calculate the the total steel bar area is 3.276 inch squared. Okay, so we need to calculate. So how many steel bars we need to use. Okay, so let's say that I decided that I will try to use number 4, number 6, number 7, and number 8. Okay, you can find a number of bars in the recent discussion about the basic design criteria for RCB. So we have a table there, so you can use that. Okay, so area for number 4 is 0.196. Area for number 6 is 441, and so on. Then we will just divide this total area in this corresponding area so that we can calculate the total number of bars per this number bar. Okay, so for number 4, we need 17. Then for number 6 is 7. Number 7 is 5. Then number 8 is 4. So which is we need to use? Okay, so we need to take account the economic aspect. So I think it's the number 17 is very plenty to use. So I think it's cancel na. Number 6 also is daghan-daghan lang po. Number 5 is good, but the more economical is number 4. So we need to use number 8 bar, which is we only need 4 bars. So after that, we can calculate now the total size of our beam. Because we already have the total number of bars, we know the cross-sectional area. Okay, so we need to calculate, look at this figure here. So we need to calculate the total height of this beam. So I express that into each. So remember that D is just the distance from here to the centroid of the center of this bar. Okay, so B is fixed. Okay, so we calculated that D is 19.5 inch. Okay, but the diameter of number 4 bar is 1 inch. So therefore, we should include the half of this bar, which is 0.5, right? Then this stinger here, this black line here, we will use this. So we will use a number 3 bar for this. So the diameter of number 3 is 3 over 8 inch. Okay, so we will include that because it's the total diameter man na ma-consider niya dere. Then we will consider a 1 inch cover. Remember ang sa definition sa cover ha. Okay, so we need to consider the cover 1 inch. So therefore, the total height is just the sum of this D plus the half of this bar plus the diameter of this bar here, this black one, and the cover. So therefore, the total height is 21.375 inch. So we have now the total dimension of our beam. So we just need to check if it is correct, if it is safe to use. So we can use standard for American standard for concrete, no, but the very easiest way to calculate or to check if your design is good is using this formula, the calculate the still area. So just manipulate lang to express that rho is just equal to AS over BD. Then we can calculate that rho or the reinforcement ratio for this. If we will use 19.5 here, BD is okay. We will not use the 21 point ko na 0.0115. So it's quite closer because the reinforcement ratio katong gadina is 0.012, then here is 0.015, so it's quite different. So you can say that our beam is safe to use. Okay, so that's it. That's how simple it is to solve or to design a reinforced concrete beam. Okay, so I attach reading material for fractional analysis. That's quite difficult to discuss lagi, but it's formula based lang man pod. But you can read that so that you can verify na lang sa mga formula nga atong gigamit. Okay, so that's it. Thank you. Goodbye.